So let's look at f of x equals 1 over x, and let's find f prime of x, the first derivative, and f double prime of x, the second derivative. This is so much easier if we remember that we can use algebra to rewrite f of x as x to the negative 1. Because then f prime of x is a straightforward application of power rule, which becomes negative 1 times x to the negative 2. And then second derivative is just the derivative of f negative 1 times x to the negative 2, which is f double prime of x equals negative 1 times negative 2 times x to the negative 3. F double prime of x is equal to negative 1 times negative 2 times x to the negative 3. Negative 1 times negative 2 is positive 2 times x to the negative 3. And then I can say, well, this is a negative exponent, so it wants to go down. So f double prime of x is equal to 2 over x cubed. That's if you remember to rewrite using algebra so that then you can use power rule. If you don't remember that and you try to do this with quotient rule, life becomes much more unenjoyable. So if I rewrite this with t equals 1 and b equals x, then I have t prime equals 0 and b prime equals 1. So I would end up with f prime of x equal to t prime b minus t b prime all over b squared, which would be 0 times x minus 1 times 1 over x squared. Now, hopefully at this point, I see this 0 times x, and I realize I can make that become 0. So that this is 0 minus 1 over x squared simplifies to negative 1 over x squared. In which case I end up at the same place and no real harm was done. If I don't realize that and I leave this out here, then when I go to find f double prime of x, it becomes a lot harder. So this is one of those situations where using algebra to simplify makes life a lot easier, especially as you start finding higher derivatives.